So in question 7, part A is asking us to take the number 11 and add multiples of 30 to it to produce a list of numbers that begins 11, 41, 71, 101, 131. And it says so far all these numbers in the list are prime, but show that this will not always be the case. Okay, so I'm going to start with A. What we're doing here is we're taking 11 and then we're adding multiples of 30. So in the first case, it's going to be 0 times 30. So we just get 11. For the next number, we're multiplying 1 by 30. This gives us 11 plus 30, which is equal to 41. And then we just continue this pattern. So 2 times 30 plus 11 is going to be 71, and so on, like that list that we've been given. But we can see here, if we just increase what we're multiplying 30 by, once we get high enough, we're eventually going to get 11 plus 11 times 30. And in this case, we're going to get a number that's actually divisible by 11, and the number we get is 341. We can check this just by plugging this into our calculator. 341 divided by 11 is 31. So this means that 11 and 31 are factors of 341, and therefore 341 is not prime. So we've shown that this pattern doesn't continue for every case. All right, let's look at part B. Part B is more abstract, where it says let P be a prime number and K a counting number, and it wants us to prove that not all the numbers in the list shown there can be prime. And this is basically the same thing we did in part A, but with variables. So we've taken P, a prime number, and in the first case added 0 times K to get some number. And then for the next one, we've increased this to 1 times K. Sorry, so this is just going to be P. This one's going to be P plus K. And we've continued the pattern. So we have 2 times K here. It's going to be P plus 2K. And so we want to prove that not all the numbers in this list continuing this pattern can be prime. You can see we're going to have the same case as before, where if we continue this far enough, whatever P is, we'll eventually get a number or term so that P, we're adding actually P times K here. Whatever P is, this will eventually happen if we continue this on long enough. And so we can see that this number, P plus P times K, is going to be divisible by P, and therefore it will not be prime. So we've shown that all the numbers in the list, they will not always be prime.